Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over section 7.0b of our series on multiplying, dividing, adding, and subtracting fractions. We're going to be looking at how to review reduced fractions in this presentation. And a sample problem that we're going to be covering is depicted here. Reduce the given fraction 4/6 completely. So we can see how the factors of 4 and 6 are outlined, and the common factor is used to reduce the fraction. The prerequisite video for this presentation is finding common factors. If you haven't reviewed that or mastered that skill, you can scan this QR code right here to gain access to that prerequisite presentation, so it'll be easy for you to master this tutorial. Don't forget, we have practice problems at the end of this video presentation for you to practice to demonstrate mastery of the contents covered in this tutorial. The instructions are for us to reduce the given fractions completely. Another word for reducing the given fraction or a given fraction completely is basically writing down the fraction in its simplest form. Okay, simplest form is the same thing as reducing completely. So let's just put that in parentheses here. So we're asking you to rewrite it in its simplest form. Before we go ahead and attack some problems, let's review the steps. Let's take a look at the steps that will guide our problem solving process. Okay. All right, so here are the steps. All right, so in the steps, the first thing we're going to do is we're to find the common factors. All right, so let's outline the steps. Number one, you have to find the common factors of the number of the numerator and the denominator. Okay, so find the common factors of the numerator, let's just write it as NUM, and the denominator. All right, so after you find the common factor or factors of the numerator and the denominators, you're going to proceed to use the common factors to reduce the given fraction. Okay, if you don't know how to find the common factors, then you want to review the lesson by the prerequisite lesson by scanning this QR code right here. Okay, now step two, there are two different ways you can do this. One is fast and a little bit more difficult, and the other is slow but is much more straightforward. Okay, so I'm going to go over both methods that you can use here, and depending on the level of complexity of the problem, one could be better than the other. All right, so after finding the common factors of the numerator and the denominator, step two for the, I'll call this the GCF method, you're going to divide the numerator and denominator by the greatest common factor. Okay, so out of all the common factors, the biggest one is called the greatest common factor. So divide the numerator and the denominator by the greatest common factor. That is also known in short as the GCF. Okay, so when you divide by the greatest common factor, guess what? After that, you are done. The beauty of the greatest common factor method is that it is the fastest method. Okay, it is fast, but another thing about it is that it is slightly more difficult in the sense that you have to exhaust all the common factor possibilities of the two numbers, so slightly harder, depending on how good you are with your multiplication facts. If you know your multiplication facts, then it might not be too difficult. But if you still have, if you haven't mastered all your multiplication facts to higher numbers, then this might be a little bit difficult. Okay, so if you don't want to use this method of finding the greatest common factor, we're going to go over another method, two. So that's one way of doing it, the GCF method, and the other one is just simply the common factors method, okay? So after doing step 1, finding the common factors of the numerator and the denominator, you're going to divide the numerator. I'm just going to write it as NUM. Divide the numerator and denominator by the first common factor, okay? So this one, you're on the hunt for the first common factor, whatever it is. You don't care if it's the greatest or not. You just want to find one common factor that goes through, okay? But so you divide the numerator and the denominator by the first common factor, all right? And then after you do that, guess what? You repeat steps 1 and 2 again. All right, so whenever you divide by the first common factor, you have to keep repeating the steps until you're done. So after that, you're going to repeat 1 and 2. You create another set of common factors for your equivalent fraction that has been reduced by that common factor, first common factor, and then divide, and you keep repeating. You repeat until when? You repeat until there are no common factors. There are no common factors, all right? And the thing about this that makes it long is that you're going to keep reducing. You might have to reduce multiple times in order to do it, okay? So this method is slow, but it's easier. You don't have to look for bigger factors. You can just use smaller factors and break down a bigger, complicated fraction situation into a simpler one systematically, okay? All right, let's take a look at the first example, number 1. Let's say you are given the fraction 9 over 21 and you are to write it in its simplest form or reduce it completely. Remember, those two expressions mean exactly the same thing. So let's look at it. All right, so we have 9 divided by 21. So we want to basically divide the numerator and the denominator by all the common factors that they have in common, and then that will result in its simplest form. So to help us with this, we're going to take a look at the skills that we covered in the previous presentation, 7.0a, on finding common factors. That's going to help us here, okay? Now you might wonder, which method are we using, 1 or 2? Well, something interesting is going to happen here. So 9 and 21, what we covered in the previous presentation, we're going to write down all the factors of the smaller one first. So what are the factors of 9? 3 is a factor of 9 because 3 times 3 is 9. 4, no. Well, we didn't check 2. 2 can't go into 9 because 9 is odd, right? 3 goes into 9 because 3 times 3 is 9. 4 doesn't go into 9. If you look at your multiplication chart with 4, there is no 9 there. 4 times 2 is 8. 4 times 3 is 12, so there's no 9. 5, no, because 9 doesn't end in 0 or 5. 6 does not go into 9. 7, no. 8, no, all the way back to 9. Bam, okay? Now we're going to list factors of 21 up to 9, okay? Because any number bigger than 9 cannot be a factor of 9, all right? A number can only be a factor of itself. It cannot be a factor of something that it's smaller than it, okay? Either itself or its multiples. So looking at 21, we know 2 doesn't go because 21 is odd. 3, just add the digits, right? 2 plus 1 is 3. 3 is a factor of 3. So 3 automatically goes. Or using your multiplication chart, 3 times 7 is 21. So 3 is a factor. 4, no. 4 is not, 21 is not in the multiplication chart for 4. 5, 21 doesn't end in 0 or 5. 6, no. 6 times 3 is 18. 6 times 4 is 24. That doesn't go. 7, absolutely. 7 times 3 is 21. 8, no. 8 doesn't go. 9, does 9 go into 21? 9 times 2 is 18. 9 times 3 is 27. So 9 doesn't go into that. So we stop. We don't have to go beyond 9. Why? Because that is the biggest factor in the smaller number 9. So we stop here. Bam. Okay, so look at this chart that we have here. And what we notice is that there is only one common factor. The first common factor happens to be the only common factor. Okay? Guess what? In a situation like this, the first factor, if it's the only factor, is the greatest because there isn't any other. The first is the greatest common factor. So in this case, it doesn't matter if you use the method on the left, the GCF method, or the method on the right, the common factor method. You're still going to get exactly the same thing. Since there's only one common factor, you just need one step to achieve full simplification. All right. So this common factor, which is 3, what we're going to do is we're going to use it to reduce this fraction. We know that 3 goes into both of them. So we're going to go ahead and divide these two numbers by 3. Divide the numerator and the denominator by the same number, by 3. Okay? So when you divide the numerator and the denominator by 3, the same number, you're not changing the magnitude of the fraction. You're just changing the form. To what? To the simplest form. Okay? Alright, so when you divide 9 divided by 3 is 3. 21 divided by 3 is 7. There's no need to repeat this step again because the only factor is the greatest common factor and it's namely 3. Alright? So that tells us that we are done. The reduced form of 9 over 21 is 3 over 7. Okay? So remember that every fraction has an infinite number of forms. Okay? But there is only one reduced form in its infinite number of forms. So when all those infinite number of forms of a fraction are reduced completely, you always end up with exactly the same number. So that's the beauty of simplifying fractions. It doesn't matter the form that you have. When it's completely simplified, there's uniformity across all different forms. Okay, let's take a look at another example, number 2. Now let's say you are given the fraction 10 over 12 and your task is to reduce it completely or write it in its simplest form. Okay, so we have 10 divided by 12 and we're going to go ahead and do step 1. We're going to find the common factors. Okay, so we have 10 and 12, the numerator and the denominator. We're going to start by listing all the factors of the smaller of the two, which is the numerator 10. So the factors of 10, if you go through your lists, are 2, 5, and 10. Okay? The factors of 12 are 2, 3, 4, 6, and 12. Okay? Now, if you notice, you have exactly one common factor, and that common factor is 2. And this is the same case as number 1, where you have only one common factor. If you have just one common factor, that's also your greatest common factor. So just by dividing by that number, since it's the greatest common factor, the resulting form is your simplest form, since there is nothing else that you can, no other identical number that you can divide the top and the bottom by to achieve a simplified form. Okay? So we're going to divide the numerator and the denominator by that common factor, the greatest one. Remember, whenever you reduce by the greatest common factor, you're automatically done, which is the case here. Okay? So when we divide the top and the bottom by the greatest common factor, 10 divided by 2, you get 5. 12 divided by 2, you get 6. Since we divided by the greatest common factor, so This 2 basically came from our common factors chart right here. Okay, so since we divided by the GCF, that's our final answer. Okay, so the simplest form, which is the same thing as the reduced form, completely reduced form, the simplest form of 10 divided by 12 is what? Is 5/6. Ladies and gentlemen, that is our final answer. Okay, let's take a look at one more example, a slightly more involved example, where we're going to attack it using two methods, the two methods that we talked about in our steps, okay? So for number 3, let's say that you were to completely reduce the fraction 30/42, or write it in its simplest form. Okay? All right, so the first method we're going to use is the fast method, which is the GCF method. All right, and then we'll show you the other method, which is the first common factor method, method 1, which is the GCF method. We have 30 divided by 42. So what we're going to do is we're going to list all the factors of 30 and 42, all of it, and then look for the greatest common factor. Okay? All right. So, bam. Oops. Do that. So we have 30 and 42. Now let's go ahead and list all the factors of 30 and 42, and then look for which one is the greatest one. All right, so your factors of 30 are 2, 3, 5, 6, 10, 15, and 30. All right, and then your factors of 42 are 2, 3, 6, 7, 14, 21, and then 42. Okay? All right. So, what are the common factors here? 2 is a common factor. 3 is a common factor. Okay. What else? 6 is also a common factor. Anything else? No. So we have 3 factors here. Ladies and gentlemen, when we use the greatest common factor, then we're done, basically. If we use the greatest common factor to reduce, then we're done. If we use other factors other than the greatest common factor, then we still have to keep making sure that every other factor or the repetition of a particular factor is completely taken out first before we're done. Okay? So in this first method, which is the GCF method, we're going to pick the biggest, the greatest common factor. This guy right here is the greatest factor that's common to both numbers, 30 and 42. So we're going to take that number and divide the top and the bottom by it. All right? We're trying to be quick here. That's why we're using the greatest common factor as a number to reduce by. So when you do that, you're going to get 30 divided by 6 is 5. 42 divided by 6 is 7. Bam. There you go. Your answer is 5/7. Okay? Now, what if we didn't want to do that? What if we wanted to use whichever factor comes first? Okay? So, method 2 is the first common factor method. So first, method 2 is the first common factor. First common factor. Okay? So we're trying to find out the first number that goes into both of the numbers. So we have 30 divided by 42. and then we have the number 30 and 42. So the goal here is want to find the first number that goes into both of them. Okay, so if you look at the two numbers, you notice that, oh wait, they're both even numbers. So what do you know about even numbers? You know that 2, okay, the first candidate, we're not looking at 1. The first candidate we're looking at is 2, right? 2 goes into both of them because they're both even, right? So that's automatically a common factor. So since 2 is a common factor, the first one, we don't care if there are other ones. We're using the first common factor method. We're going to divide by 2, top and bottom, since it's the first common factor that we found. Bam. When you reduce that, divide by that, you get 15 divided by 21. Now, since we didn't use the greatest common factor, we have to make sure that there isn't any other common factors. How do we do that? Well, we have to repeat step 1 by finding the common factors of 15 and 21. The first one, okay? What's the first common factor of 15 and 21? So they're both odds, so we know 2 doesn't go into them. How about 3? Does 3 go into 15? Yes. 3 times 5 is 15. Does 3 go into 21? Absolutely. 3 times 7 is 21. Oh, we found another factor. 3 is another factor. Is it the only other factor that's left? Well, we don't know. We're just looking for the first common factor. Okay, so now we're going to divide the partial reduction. It's not completely reduced by 3. Okay, so divide by 3, the top and the bottom. That was the next factor that we found. 15 divided by 3 is 5, and 21 divided by 3 is 7. Are we done? Well, we don't know. We didn't exhaust all the factors. Okay, so we're going to make sure that there are no other common factors present between the two numbers in this reduced form. So we now look at 5 and 7 and say, okay, what are the common factors of 5? 5 is prime, so the number that goes into 5 is 1 in itself, so 5. And then what goes into 7? 7 is also prime, so nothing else goes into 7 but 7. Are there any more common factors in the fraction 5 divided by 7? Any more common fractions between 5 and 7? The answer is no. There are no more common factors. When you get to the point when there are no more common factors, that fraction that you use to generate that common factors chart is your simplest form, 5 over 7. Okay? So let's go ahead and write down the answer. The simplest form, or the reduced form, of 30 over 42 is 5 over 7. So ladies and gentlemen, which method do you prefer? Do you prefer the greatest common factor method, one and done, or do you prefer using smaller common factors? Whichever one shows up first, you use it to do a partial reduction until you're done. Let us know which one you prefer in the comment section below and tell us why you prefer the method of your selection. Alrighty, ladies and gentlemen, now it's your time to do some practice problems to demonstrate mastery of what we've been talking about the past 20 something minutes. So your goal is to simplify the given fractions completely or write them in their reduced form. Alright, so go ahead and pause the video presentation, try out these 6 problems. When you're done, click on the playback button and we're going to reveal what the correct answers are. Alrighty, ladies and gentlemen, hopefully you had a chance to try out these 6 practice problems. Here are the correct answers. Take a look at question number 3. You notice that not all fractions are reducible. Okay, you're not always guaranteed to find a common factor that you can reduce a fraction by. Alright, so number 3 is kind of like a trick question where you do not have a simpler form. So how well did you do in these 6 practice problems? Let us know in the comment section below if you got them all right or you did really well. go ahead and destroy that like button. If you have any questions about these practice problems or what we talked about in the tutorial, specify it in the comment section below and we'll be glad to assist you. Thanks so much again for watching this presentation. Don't forget to support our channel by liking, sharing, and subscribing, and also hitting the bell notification button to get notification of future updates. Tons of support resources can be found in a link in the description below or mathgotserved.com. Thanks again for watching and have a wonderful day.